everybody. Welcome to CSG's Semester 10 Marine Science presentations. Thank you so much for coming out. We're really excited to share our project with you. I am Maya Jakes and I am from Surrey, Maine.
I'm Kiley and I'm from Newport Beach, California.
And I'm Greta and I'm from St. Paul, Minnesota.
And this is our project, From Coast to Coast, Microplastics from our Macroworld.
So for our project, we focus mainly on microplastics. And microplastics are minute plastic particles that are less than 5 millimeters in size. And they come from two different sources. The primary source is microbeads, which are small plastic beads that are manufactured to be that small. And these can be found in personal hygiene products like toothpaste and face washes. And then the secondary source is plastic deterioration. And an example of this is if a large piece of plastic falls into the ocean and it starts to break down, then small microplastics come off of that large piece and they stay in the ocean forever. And we focus mainly on fiber microplastics, which you can see in that picture right there, and they came from mostly synthetic clothing and fleece. And if you can see in that picture, there is a blue strand of microplastics, and we think that it came from this fleece that was washed with that sample.
You might not think that microplastics are inherently harmful to the environment, being just minuscule fragments of plastic, but when they are ingested by animals, like when nurdles or small resin pellets are ingested by turtles, or when microplastics are ingested by blue mussels, which are filter feeders, and zooplankton, they can be very destructive to those animals. They also, once they're in those animals, they make their way up the food chain because of what else eats the animals. And the plastics bond to chemicals like PCBs and flame retardants, which can cause cancers, and those chemicals can make their way up to humans when we eat seafood.
So where are fiber microplastics coming from? They are sourced from synthetic clothing like your running shirt or your Patagonia fleece. And when you put them in the washer and through that cycle, all the wastewater is pumped into a drain pipe. For some people, that wastewater goes into your sewer system, and for some people, it goes into a wastewater treatment plant. For the sewer system, it can leach into the sediments around the sewer system, and with the help of a really big rainstorm or time, it can make its way into the ocean and the marine ecosystems around there. For wastewater treatment plants, most of the fiber microplastics are too small to be caught in the filters and will wash down into the ocean regardless.
So our research question was, what kinds of microplastics is CSG producing and how can we limit them? And we chose this research question because we're really interested in what microplastics we're doing in the environment because they become a really relevant problem. And we decided that we wanted to find out any way that we could help make the production of microplastics into the ocean less than it is now.
Our first hypothesis that we thought was that we thought that the microplastics that we found in washer runoff would be similar to the microplastics that we found in the ocean. We thought this because we think that the washer runoff is a significant contributor to the microplastics in the ocean.
Our second hypothesis was the density of microplastics in washer runoff would be less than the density of microplastics in ocean water.
Our third and final hypothesis was that if microplastics were found in the washer runoff, they'd be more abundant in the cold wash sample because we believe that the cold water is more gentle than the hot water.
To begin our project, we kind of took apart our bathroom a bit. And so this is where we keep the laundry machines, and we took the drainage pipe from the washing machine that goes into the plumbing system and put it into this 31-gallon trash bin. We were expecting about 10 to 15 gallons of water to come from our washes of clothing because we have a front-loading washing machine.
This table is showing an average load of laundry that we did. So for each load, we put through 2 pairs of blue jeans, a synthetic shirt, a pair of wool socks, a fleece, and 2 cotton shirts. we wanted to sort of recreate a normal load of laundry, something that everybody would be washing, and not all synthetics or not all non-synthetics. We washed this load of laundry, but with different items representing each fabric. And we washed it on 3 different temperature settings: cold wash, cold rinse, warm wash, cold rinse, and hot wash, cold rinse.
And then for sampling, we wanted to make sure that we took an even amount of, like a mixed up amount of the sample. So we grabbed a stick from the front yard and stirred the liquid for 30 seconds. And then using a mason jar, we had 3 different ones, we dipped this jar into the bin and got our sample, and then we labeled it with duct tape so we knew when it was taken and what wash cycle it was. And as you can see in this jar and in that picture, the liquid is extremely blue. And we believe that since we washed mostly dark blue jeans in these cycles, that the dye in the jeans came off into the sample water. And when we washed the hot cold sample, it turned slightly green because we washed a green pair of jeans. So we believe that it's blue from the dyes.
Our next step was a bit unexpected because we had planned to just take our 100 milliliter sample from the washer runoff and filter it, but we weren't able to do that because when we tried to do that, the concentration and density of microplastics was far too high to actually count accurately. And so instead, we used a glass pipette to measure out 1 milliliter of water, and then mixed that with 100 milliliters of tap water, and then we were able to count the microplastics.
With the help of a fellow group, we had them collect 500 milliliters of ocean water from the Freeport Town dock. We chose the Freeport Town dock because it had the easiest access to the deepest water, and we were hoping to get the most conclusive sample that we could.
Our next step was filtering the samples so we could look under the microscope with them. And we had 11 micron filter paper that we put inside of a ceramic funnel. And then we attached the funnel to a glass beaker, and the glass beaker had a hand pump and a tube connected to it, so that when we poured the liquid into the funnel, we could create a vacuum seal inside of the beaker and speed up the process of filtering.
And then we counted. We had 5 different filters to count, 2 from the ocean, and then 1 from each wash that we did. And so we had drawn grids on each filter prior to filtering, and we're able to use those grids to help us accurately count by marking which squares we had already counted. And we used a handheld counter to keep track of our findings.
This graph is showing all of our samples normalized to liters. The washer runoff samples averaged from 36,100 microplastics to 14,800 microplastics per liter, and the ocean sample was only 2,300 microplastics per liter.
Only.
This graph shows the exact number of microplastics that we counted in each sample. So starting with cold, we found 361 microplastics total in the sample. In warm cold, we found 253 microplastics, and in the hot cold, we found 148 microplastics in the sample.
And we did end up finding similar microplastics between the ocean water and the washer water, and they were similar visually by like their size, color, texture, and shape. This supported our first hypothesis, and we had also contacted Polartec, the leading fleece producer, and asked them what their most popular color of fleece was, because we wanted to compare that to our findings, and they said that their most popular color was black, which was something that we did see a lot of in the ocean samples and has in previous CSG groups been a dominant color. The density was the greatest in the cold samples and then decreased from there, and with over 100 microplastic difference between each temperature setting. And this isn't conclusive data because we weren't able to complete as many tests as we would have liked to. We only got to complete one test for each wash. And for our third hypothesis, the ocean did have the least amount of microplastics found, which is helpful to know because it's good to know that what we're producing isn't highly concentrated in the ocean.
So while we were doing our project, we had lots of questions, and everybody around us had lots of questions. A few of these questions were, what would be the results of washing one single article of clothing and seeing how many microplastics that had? This would help us sort of gauge how many microplastics each article of clothing was and get a better idea for what a whole load of laundry was impacting. We wanted to know how many microplastics were in our tap water. We know that some of our water is stored in plastic bins underneath the school, and we wanted to see if that had any impact on that. We also wanted to know approximately how many microplastics is CSG producing. As an environmentally conscious school, we really wanted to be aware of the impact we're having on the marine ecosystems around us and how we can change that. We also wanted to know how much microplastics you produce when you wash your face with a face wash that has microbeads. And last but not least, we wanted to know what would happen if we washed the same load of laundry over and over again. We changed the loads of laundry every time, so we don't know if there was any data variance in that, and it would be really cool to see what the same load of laundry would yield.
So by now, you're probably feeling really guilty for distributing microplastics into the ocean. But you should know that it's not just by laundry that microplastics are getting into the ocean. There are so many different ways that they come in. And it's really important to spread awareness of this topic because when I first got assigned to this project, I had absolutely no idea what microplastics were. And so awareness is really important. And also it's really important to spread awareness so that we, as active participants in the environment, can find a solution to help limit the amount of microplastics found in the ocean.
We'd like to thank some people, including our wonderful teachers, Liz Holiday, Ann Bardaglio, and Kate Kairos.
We'd also like to thank our fellow students for letting us use the washing machines that we all use, and also our lovely RAs for allowing us to tear apart their bathroom during data collection.
And we would like to thank you guys for coming out tonight and being part of this. We are really grateful for this opportunity, and without a lot of you, we wouldn't be here.
We'd like to open this time up for any further questions.
I would have thought that the hotter the water, the more plastics would have broken off or whatever it is and ended up in your samples. And yet, I would have been exactly wrong because it was the cold water. Any ideas about that?
Well, we had hypothesized also what you thought, and we think that maybe the particles might bond together more in the hot water rather than being distressed.
Did you test the water from like the tap?
No, we didn't. That's something that we'd like to do in the future.
Yeah, I want to know that.
What we're
How
drinking,
much
right?
plastic are we drinking?
Yeah, it's a good question.
Did you do any variance in soap that you were using, or were you not using soap?
We did not use any soaps. Or, we did. We used laundry detergent.
Besides temperature, we didn't change anything about the laundry loads that we did.
So is it possible that some of the microplastics were coming from the actually laundry soap?
Well, in like the personal hygiene products, you can actually see the microbeads inside of the soap product.
Under a microscope or with your eye?
With your eye.
Really?
And
Wow.
so we could not see any visible microplastics in the soaps, but it doesn't really mean anything.
The microplastics in soaps are generally for exfoliating purposes, so it wouldn't make a ton of sense for them to be in the washer.
Yes?
When we buy products, should we be informed? Should the producers inform us as to whether or not this product contains microplastics?
Generally,
Is there information on it?
Generally, they say that it contains microbeads, which is kind of misleading because it doesn't outright say that it contains microplastics.
I think you referred to newer garments versus older garments. Do you have a sense of whether something that's 5 years old is going to put out as much plastic as something that's brand new?
We're not quite sure about that question.
What do you think about companies like Patagonia who say that they're environmentally sensitive and environmentally aware, and they're producing garments that are made of this? Do you have any thoughts on that?
Well, I was reading an article, I think we all read it, for our research paper, and it was about around last year around this time, and Patagonia released an article saying about how their fleece that was being bought or being sold was not very environmental friendly, and I think that they've so far changed that thought, but I'm not exactly sure. Yes?
I have a question from someone on the live stream in California. She's wondering, what would you do to help eliminate the problem or bring social awareness? So I guess from your perspective, what would you do?
I don't really know how to limit it because we didn't focus mainly on that. But to spread awareness, I would say trying to persuade companies fleece companies, to let buyers know that this is happening and it's from their products. But that'll probably be very difficult. Yes.
What happens to microbeads when we eat them? Do we expel them or do they stay in us?
I don't know.
Oh.
Topic for further research.
We're all beanbags.